Dear student, let's see the next topic of in the some basic concept of chemistry. Actually, there is a scientific notation. The scientific notation is nothing but there is a very large number, large or there is a very small number, large number or a very small number is converted into is for conveniently decimal form, conveniently decimal form. Okay, so this is for that scientific notation. Okay, okay. So then it's a very important in generally the scientific notation is represented as capital N into 10 to the power of small n. Okay, so here n as a integer, n as a capital N as a integer, and the small n as a real number. Okay, okay. So for example, see this value 750 comma 00 comma 000. So this we can go to representing as 7.5 into 10 to the power of 8. Okay, so here this n as a 7.5 and the small n as a 8. That mean as there is a 7.5 into 10 to the power of 8. Okay, so in generally the scientific notation is a very large number or very small numbers is a conveniently representing in small convenient decimal form. Okay, so for example the decimal point how it can move left or right we can choose. For example, see this value that is a 145,000. This we can go to representing there is a 1.45 into 10 to the power of 1 2 3 4 5. So there is a 10 to the power of 5. Okay, so here the decimal in this point onwards is moved to the left to right. Okay, this is a left to right, that is a moved in the decimal point. The exponent value as a increases. Okay, so simply very basic value of 10,000, how we can return this, there is a 1 into 10 to the power of 3. Okay, so this is the exponent power that is increases whenever the decimal point move left right to left. Okay, so this is a basic concept. And see another one value here, there is a for example 0.0000423. So we can go to write this value, that is a 4.23. Okay, that is equal to 4.23 into 10 to the power of 1 2 3 4 5 5 and 6. So that's why 10 to the power of minus 6. So here this decimal point move left to right. Actually this is a right to left. Here this decimal point as a left to right. Here the exponent value as a decreases, but in the previous case yes, right to left the exponent value as a increases. Okay, so this is a very basic in the concept of scientific notation, especially it's also already we studied in the max. Okay, so basic max. Okay, the next we can go to that two examples, either whether there is a multiplication and division and addition and subtraction. Next we go to that two point of view. One is a multiplication, and there is a division. This is a one point, and another one point of view there is a addition and subtraction. Okay, addition and there is a subtraction. Okay, so first of all multiplication and division, we can go to that this. For example, here the multiplication means the integer values are multiplied, but that exponent value we can add it. Okay, so similarly the division means there is a the integer values are divided, but in the case of exponent value are subtracted. Okay, so for example I written here there is a multiplication. Okay, multiplication, here there is a for example here a into 10 to the power of 2 into there is a b into 10 to the power of 3. Okay, so what we can do here, this a and b as a multiplied, a b into there is a 10 to the power of 2 plus there is a 3. Okay, so we can get that is a answer. So for this concept, actual the multiplication means the two integers are multiplied and that exponent value are added. Okay, so for example one of the value, see this here 2 into 10 to the power of 3 into there is a 3 into 10 to the power of 4. So what is the answer? This is a basic in the multiplication example. Here this 2 as a integer, so 2 into 3 into this 2 as a exponent value, there's a 10 to the power of 3 plus 4. So 2 into 3 as a 6 into 10 to the power of 7. Okay, so this is a answer. Okay, so then similarly there's a division. Okay, so we can go to that division. The division concept, actual that exponent value as a divided, but sorry, actual the integer are divided, but the exponent value are subtracted. For example, a into 10 to the power of 3, there is a division. There is a b into 10 to the power of 2. So this is a division method. Here a and b are the integer, so that's why here a divided by b into 10 to the power of 3 minus 2. This is the answer. Okay, so this is the answer. For example, here I can given the value. For example, 10 into 10 to the power of 3 divided by, there is a 5 into 10 to the power of 1, or there is a 2. Okay, so 10 to the power of 2. So this is the answer. Actually, there is a 10 divided by 5 into 10 to the power of 3 minus 2. We can get in that 10 by 5, there is a 2. So there is a 2 into 10 to the power of 1. Okay, so that is nothing but as a 20. Next we go to that addition and subtraction. Here for example, there is a into 10 to the power of minus 2 into plus b into 10 to the power of minus 3. Okay, so how we can solve this? First of all, we can converting that exponent value as the same. For example, here this 10 to the power of minus 2, when it will convert that 10 to the power of minus 3, yes, there is a 0 point a into 10 to the power of minus 3 plus b into 10 to the power of minus 3. So whenever we can converting that exponent value as the same, here as a converted as a same exponent value, so that's why we have written as a 10 to the power of minus 3 as a common, and this b plus 0 point a as a integer, we can solve this value. Okay, for example, we can go to that substituting the value. For example, a as or there's 2 into 10 to the power of minus 3 plus there's 3 into 10 to the power of minus 2. So what we have to actual this 10 to the power of minus 3, and here as a 10 to the power of minus 2, we can converting that this 10 to the power of minus 2 into 10 to the power of minus 3. So that's why this 2 into 10 to the power of minus 3 plus 0.3 into 10 to the power of minus 3. Actual this decimal is converted into there is a right to left, this is become to the exponent value as a increases. Actual exponent value as a increases. Okay, so there is 10 to the power of minus 2, this 2 into 10 to the power of minus 3, and this nothing is changed, but we can do change this minus 2 to minus 3. Okay, okay, so whatever that this decimal here, this converted to right to left, this value as a decreases. Okay, so here the 10 to the power of minus 3 as a common, so 2 plus 0 0.3 into 10 to the power of minus 3, we can get in the answer as that's 2.3 into 10 to the power of minus 3. So this is the answer. And we go to that subtraction. Actual this subtraction also similar concept. Here for example, there's the same value, we can add that the subtraction representation. There is here 3 into 10 to the power of minus 2 is subtracted, and there's 2 into 10 to the power of minus 3. So what we do here, this will become the actual this 10 to the power of minus 3 in converted to 10 to the power of minus 2. So what we do here, there is 0.3 into 10 to the power of minus 3 minus, there is 2 into 10 to the power of minus 3. So here is 10 to the power of minus 3 as a common. So what we do here, actual there is a minus 1.7 into 10 to the power of minus 3. This is the answer actual. Okay, so anyway, both subtraction and addition, the exponent value must be is converted as a similar value. Then only we can go to that integers, whether they have asking the addition or subtraction dependent on that. Okay, okay. Next we go to that as a significant figure. It's a significant figure. Okay, the significant figures are called as a meaningful digits. Okay, there's a meaningful digits, okay, okay. So we can, what are that significant figures? The significant figures actual, that's a figure that must be, that's a meaningful digit. Okay, so that is a the rules for that is finding the significant figures. The first rule, all the digits are significant figure. Okay, so I can written here as a significant figure in the short form SF. So the all digits are significant figures. For example, there's a 2 3 5 4, here is a significant figure as 1 2 3 4, 4 significant figure. Okay, so the next concept as the digit or the zero between the digit. zeros between digit. Okay, so this also has a significant figures. This also has a significant figure. For example, that's 2025. Here is a significant figure as 1 2 3 4 as a 4 significant figure, because this 0 is a between the two digits. That's why that 0 has taken as a significant figure. Okay, so this significant figure as a 4. The next we can go to that leading zeros or not significant figures as a with or without decimal. There is next concept as leading zeros not significant figures. For example, see, there is 0.34 here. This decimal, it's a 0 as a leading, so that this 0 as a not taken as a significant figures. So that's why here as a significant figure as a only 2. Okay, so there's a 2 significant, 4 and 3, that is 2 significant figures. And next, the trailing zeros are considering as a 2 path. That's a trailing zeros. Okay, the trailing zeros actual with decimal as well as a without decimal, the two concept. For example, this is a with decimal. Okay, with the decimal. So the trailing zeros with the decimals in the whole number, for example, as taken as a significant. There is, for example, there's 2 4.0 here. The zeros are trailing zeros. So even though this 0 has taken as a significant figure, because it's under the category of with the decimal, so that's why this considering as a 0 as the significant figure. Okay, this as a significant figure. So here as a significant figure 1 2 3, 3 as a significant figure. Okay, so in case without decimal, this cannot be as a significant figure. For example, as a 2500, here there's a decimal not possessed between 0 and the digit. So that's why the 0 as a cannot say as a significant figure. So here as a significant figure as a 2, a significant figure as a 2. Okay, so this is a very very important actually, the trailing 0 with the decimal as well as without the decimal, whether they have the 0 as considering as a significant figure or not considering as a significant figures. Okay, so the next, see that exact value as a infinitive significant figure as a infinitive. Okay, the exact value as a infinitive significant figure. The next, for the number of scientific notation as capital N into 10 to the power of small n, here as a significant figure as a capital N. Okay, so these all are, there is a significant figure rules for finding the numbers, how much of significant figures is like that. Okay, dear student, thank you to everyone. If you like in this video, you can subscribe and share your friends as well as support in this channel for upcoming new videos. Okay, thank you everyone.